Hello, I am the narrator, and today we are going to talk about Flame, a highly complex and versatile virus that has raised concerns in the cyber community. First off, what is the Flame virus? The Flame virus contains features of many different types of malicious material and can take command of many different functions in an infected computer. The actions Flame can perform with an infected computer are limitless, but often include keylogging, screen captures, and audio recordings. These processes can be broken up into different modules of the program. The Flame virus consists of 20 modules, most of which are still under investigation. These modules make a virus larger than a typical virus, but can be modified to do whatever command and control center wishes. While normally viruses occupy 100 kilobytes of data, the Flame virus consists of 20 megabytes. But how does the virus work? Where does it come from? While the origin of the virus is unknown, it is believed to come from a nation-state due to the fact that the project is too large for hacktivists to take on and lacks any profit incentive to link it to cybercriminals. Also, with the discovery of Resource 207, a module in Flame, experts are starting to draw connections to earlier versions of Stuxnet, which also contain the same module. As previously mentioned, the program works by being broken up into modules, each with specific tasks, and most still under investigation to discern those tasks. However, 3 of the modules discovered deal specifically with spreading the virus across a local area network, while the original source of the virus is unknown. The modules named Snack, Munch, and Gadget are responsible for spreading Flame across LAN networks. When the target computer activates Internet Explorer, it looks for a DNS. When the computer fails to connect, it looks for a net BIOS. The first module, Snack, provides a net BIOS that connects the target to Munch, a fake web server. Once the connection with Munch is established, the module monitors the target's activity until a request for Windows Update is submitted. Munch, upon receiving the request, receives a signed binary packet from Gadget in order to fool the computer into thinking that it is a legitimate update from Microsoft. Once the false update is installed, the Flame package is sent and installed on the target. 2 additional methods used to infect computers with the Flame virus involved using a USB stick. One, called the autorun infector, used an autorun.inf file from the early Stuxnet program using the shell32.dll trick that automatically runs the virus when the flash drive is plugged into the computer. The second method, called Euphoria, spread on media using a junction point directory that contains malware modules and a link file that triggers the infection when its directory is opened. But what does this mean? What can Flame do? With keyloggers, audio recording, screen captures, and network traffic sniffers, Flame makes any sensitive information that passes through an infected computer or network vulnerable. Passwords and code typed into infected computers can be recorded and used. The audio recording allows the virus to take control of an audio device, such as a microphone, and record conversations that are within range of the device. Also, any designs or sensitive documents that are on the monitor of an infected computer can have screenshots taken when the desired programs are running. As illustrated in this picture, Flame has already been used to infect several Middle Eastern nations, including Egypt, Iran, Israel, Palestine, Sudan, Lebanon, and Saudi Arabia. The Flame virus can have a powerful impact on a targeted organization's resources, and the Flame user will have access to the target's encryption keys, financial information, passwords, and any research and development that is done on or with computers. But how does Flame affect us, you may ask? We'll take into account the following scenario. Corporation A is creating a new device to be released to the public. Corporation B wishes to steal the product designs and patent them before Corporation A can. Corporation B develops a modified version of Flame that is disguised as a legitimate email to an employee working on the product. The employee opens the email and unknowingly infects his computer with the virus. Flame then begins to monitor all projects open in the design program the employee uses to create the product. It could then record conversations he has with other employees near his computer, take screenshots of product schematics, and copy encryption keys as well as sensitive documents to a server in Corporation B. Furthermore, it could monitor the employee's keystrokes and steal his login passwords to accounts he accesses such as Facebook, which would then create an uncomfortable situation when he comes home to his wife asking why his relationship status has changed to single. Not only does Corporation B now have the schematics to the device Corporation A was planning to release, but they also now have the encryption keys that Corporation A uses to securely communicate throughout its network of computers. The entire company has now been compromised, and Corporation B can freely access any and all information Corporation A has on its computer networks. Furthermore, Corporation A may not be aware of the intrusion and may continue to use now compromised security measures. This type of intrusion could result in the discreet theft of billions of dollars worth of products and information, potentially causing Corporation A to go bankrupt and be forced to go out of business. The frightening part of the scenario is that it is entirely possible and could be happening as I speak. And it's not just corporations that this affects. Flame was originally intended to steal sensitive information from Arabic states, but could easily be repurposed now to steal information from larger nations that is more sensitive and more devastating. For example, a nation could repurpose Flame to steal sensitive information such as troop movements, nuclear designs, and or new weaponry from the United States or other first world countries. This will require a major overhaul in security systems that could take years to fully establish and cost billions of dollars to do. Flame is a serious threat to cybersecurity that isn't even fully understood, and may not be fully understood for years to come.
Flame is by far one of the most complex pieces of computer malware that has ever been developed and deployed. It is so versatile that it could become a serious threat to many of the components of the cyber society that we now live in today. Its multiple methods of infection combined with its clever ways of avoiding detection could result in a new breed of malware that would be as hard to detect as it would be devastating. Imagine if these kinds of threats became more common. Every conversation near or on a computer could be instantly heard by an attacker. Any documents typed or saved on a network could be stolen or copied. Credit card numbers, social security numbers, PINs, financial records could all be used by criminals without the victims knowing a thing until it's too late. This could be the dawn of a new era in information security, where the development of malware and its capabilities rapidly outpace the development of security technologies.